Today we're talking about reactions. And we're not talking about the reactions from a bad pickup line or the reactions from cooking a meal for somebody or not cleaning your bedroom from your parents. We're talking about chemical reactions. As I mentioned, we're talking about chemical reactions today. Hopefully you had a chance to kind of watch or learn about how chemical equations are formulated. Today we're talking about the four main types, okay? So it's important to kind of have that background knowledge that equations start off with the reactants and they yield the product, because that's kind of what we're going to be talking about through these four different types. The first type we're going to talk about are called synthetic or synthesis reactions. Basically, you might know that word because like synthetic leather, it's something that's created, right? Man-made. In this case, we're talking about synthetic making a product. And what I mean by that is kind of almost picture like two Legos, right? There's a red Lego and there's a blue Lego, and then you're making something, and you kind of put those two Legos together. The same thing happens with a chemical synthetic reaction. And what we're talking about is we might have like two hydrogens plus oxygen, and we yield H2O. We created water, right? So we had two elements by themselves, right? That's why that plus sign there, and we built water, okay? So it underwent a reaction, okay? I like to always put like a letter instead of the chemical, right? So like A plus B yields AB, right? So that might help you out to kind of substitute that in if you ever see an equation, right? The second type is kind of the opposite. Instead of building, it's also we're like destructing or breaking apart. It's like a deconstructed sandwich. We start with sandwich and we deconstruct it. So this might be looking like we have started with water, so that's a reactant, and now it yields two hydrogens plus oxygen. So we start with water, what was a liquid, and now we end up with two gases. So we actually split it, broke it apart, right? You might have even done an electrolysis lab where you use electricity to split that water. It's the same idea. That's decomposition. All right. That actually brings up a good old story of back in the day. There was somebody that was actually, they lived kind of in New York City and they didn't work too far away, so they always walked home after work, right? So they took a nice little shortcut. And always on all shortcuts, you end up through a cemetery for some reason, right? And as they were getting close to the cemetery, they heard music. It'd play for a couple notes and then it'd stop. It'd play for a couple notes and then stop again. And then finally, as they got closer to the cemetery, they noticed one of those little kind of like this walk-in like little houses in the cemetery is a crypt, right? So they went in because, you know, why not? They're curious. And as they're going in, they hear the music getting louder, and again, it stops, keeps playing, stops, keeps playing. There's a staircase that leads down, and eventually they go down in this room. It's lit. There's a piano in there, and there's some famous musician, right? You see him play a few notes, and then he goes up to his page, and then he looks like he's writing. He's actually erasing. He's like, "What are you doing?" He goes, "I'm decomposing." Sorry, terrible joke. I had to do it every year. But either ways, it's that idea that you're breaking apart. So it's almost like that music, you're pulling those notes apart. That sandwich, you're pulling it apart, right? You have a skateboard, and you crash, and now you have a board, and the wheels are apart. So you're decomposing, right? Whatever that compound is. It's almost saying like AB yields A plus B. So we have synthesis and we have decomposition. Now we have two left. The next one is single replacement. This is a chemical reaction where we have two reactants. One of those is kind of by itself and the other one's paired up with a different element. Okay? So think about it kind of like, it's almost like a date. There's a boy and a girl that are together. They're an item, and they run into somebody else who's single. So maybe, the guy and the girl, they run into his ex-girlfriend, which is a bad idea. But what happens at the end is maybe the girls switch. So there's a single replacement going on there. And that's perfectly, like exactly what happens with this in chemistry. So picture, you could do it with letters. So AB plus C. And what does it yield? It yields AC plus B. So you see that switch of the B and the C. A good chemical equation that does this, right? HCl, hydrochloric acid, plus sodium, right? What ends up happening? The hydrogen, right, switches with the sodium, right? So hydrogen's left by himself, and we get sodium chloride. So those are the ones that actually leave together, right? So if you need to picture it as like a date gone bad and somebody ends up switching, that's fine. That might help you out. But it's kind of like saying AB plus C and then it's AC plus B, all right? So that switch. I always think about it, something was alone at the beginning and something's alone at the end. The others are coupled up. Okay, so that might help you out with single replacement. And then double replacement, right? This is the fourth and final type of chemical reaction. This is the ultimate. I don't know if it's bad or not. I just picture two couples dating and they switch. So it could have been, hey, there's two couples, boy and girl, right? Two couples, I don't know, they're double dating, right? And they end up yielding at the end of the day. I don't know, the guys are like, we can't do this, right? We don't want to go to XYZ, so maybe it's, you know, they got suckered into a really bad rom-com or romance movie, and they leave together to go play their PlayStation 5, and the girl's like, forget this, we're going to watch the movie together. So maybe it's the guys leave together, and the girls leave together, right? So there's a double switch going on there. If I were to use letters, I like to say like AB plus CD, and what yields, what happens at the end, again, it's almost like there's like the AC and BD. So they're all bonded together with something. Nobody's leaving by themselves, right? They still have somebody in their lives, so whether it's a friend or whoever. A good example of this, right, might be NaOH plus HCl, right? And what happens, what yields, right, those hydrogens, okay, end up bonding with the oxygen to create water, H2O, and the Na and Cl, they end up bonding together. So again, something's leaving both couples and they're leaving together, and those other two parts are combining. So again, a little tricky. However, again, if you think about it, synthesis and decomposition are basically opposites. Single replacement, double replacement. Single replacement, there's always something by itself. Double replacement, it's kind of like a double date where they just switch. It doesn't matter if there's just the girls switch or the guys switch in that dating couple. But there's something that's always combined at the end. Now, keep in mind, as much as these are the simple four types of chemical reactions, some reactions actually have chain reactions that go on and on. Sometimes there might be multiple types of reactions in the same chemical equation just because things get crazy. So not to overthink it, these are the basics of the four types of chemical reactions. Alright, see you next time, see you in the next video.